Lesson 10: Device Discovery and Management. In this video lesson, guys, we are going to describe with you some protocols which are helping us to discover and manage Cisco equipments, and not only Cisco equipments. And by the way, this is the last lesson in the book of the CCNA RS2, Routing and Switching Essentials. And let's take a look what kind of protocols are described here. So they are CDP, a Cisco Discovery Protocol, LLDP-LINK Layer Discovery Protocol, Network Time Protocol, and SYSLOG Protocol, which is helping us to create syslogs and save them on external servers. Starting from the CDP protocol, so all the equipments of the Cisco, routers, switches, they are exchanging the packages, CTP messages between each others by default. When you are turning on equipment and plugging it to another Cisco equipment, then immediately they start to exchange CDP protocol messages, which is working on layer number 2, and which is helping to equipments to find out the neighbors, to understand to which neighbors these equipments are connected and to which interfaces they are connected, and what is the operating system version of that equipment which is connected to our device. So for example, in case if you have such kind of situation, you have a switch which is connected somewhere and you don't see what kind of equipment is placed on the other side, it is good if your CDP is working and you can type the command show CDP neighbors in the switch, so that you will see that there is the router. And here is the example of how we can turn on and turn off our CDP. So by default, all equipments of Cisco, networking equipment of Cisco, is working with the CDP. But if it is turned off, so you can turn it on and you can tune it. So when you type in the in the privileged executive mode show CDP, you can see that it is working, and you can see that the sending CDP packages every 60 minutes. So we have periodic updates each 1 minute, and we have the hold down timer, which is getting 3 minutes. And also we have information about the version of the protocol, and you can turn off or turn on the CDP in separate interface by using interface configuration and the command CDP enable, or you can turn off or turn on CDP in the global configuration mode, which will impact all interfaces of your equipment by using no CDP run or CDP run. Discovering network by CDP. And let's take a look for this example in which we are looking for the routers 1 CDP neighbors. So in router 1 we type show CDP neighbor detail, and the CDP shows us that on the other side we are connected to the host name as 1. So device ID is actually the host name, and we can see that its IP address is 1 and 2. And we can see also the platform. We can see what kind of operating system is installed on our neighbor's equipment. And if we'll take a look for the switch 1's show CDP neighbor, we can understand that from one side we have router 1, which is listed here, and it means that in the question mark here we have switch 2, which is connected through a fast Ethernet 04. So here we have fast Ethernet 04, and from our side it is also FA 04. This is our port number. This port belongs to remote device. Also we have capability information, so that we have, for example, in router we have so description. This is router. It can make B, so source road bridge. It can make S, it can make switch, it can make IGMP protocol are available on that equipment. And let's take a look for the switch, where we have S. It means that it is switch, and it can work as a repeater. Well, in the same way, so as you saw it here, it is very useful protocol in case of the managing and discovering the network, the topology. we have to say that this is the CISCO discovery protocol. It means that only CISCO equipments run this protocol, and it's not compatible with other equipment of different brands. And we have the alternative protocol, which is called link layer discovery protocol, which is working with the same logic as the CDP protocol and helping to discover the network even if your equipment is not Cisco. So you can connect one Cisco device to, for example, Juniper equipment, and you can understand what kind of device is connected on the other side, to which port, and almost the same logic of the protocol. So you can make tune of it, so you can turn it on or turn it off by using command in the global configuration mode LLDP run or no LLDP run if you want to turn it off. And also you can make a regulation like LLDP transmit and LLDP receive on the interface, so that we have also timers 30 seconds and 120 seconds. And let's take a look what kind of information it can provide to us. In switch 1 we are making decision to see what kind of neighbors of LLDP do we have, and it's saying that we have from one side we have router 1, from another side is switch 2. And what else? And also here is some information about their ports and about their capability, what kind of job they can do. And let's take a look for the CDP protocol in action. So we have a small topology in which we have router which is connected to switch, and we'll take a look for show CDP neighbors, and we can see here the neighbor which has the name switch, and it's connected to our interface gigabit 00 to interface fast Ethernet 01. Or you can type the command detail which will show you more information about our switch. So the switch which is running the software LAN base M with the version like this, and also we have information even on which date this operating system being compiled and by whom. And if you want to work with the LLDP protocol, then you have to go to global configuration mode and type the LLDP run on the router. And let's do the same on the switch, because by default it's not running on Cisco equipments. So LLDP run. So after a while we'll take a look for the output of our LLDP neighbors, so that we can see almost same information as we saw from the CDP neighbors. You see? So it's like alternative work of the CDP when you don't have when not all of your equipments are under the Cisco brand. Alright, setting the system clock. How we can set the clock in the equipment, in the router or in the Cisco switch. So we can just set a command like clock set and then define the time, then define the date and the year. Well, we have the ability to work with the synchronization of the time. So it is responsible for that synchronization is the NTP protocol, Network Time Protocol, which is working as a server and which is providing synchronization to all equipments in the network, so that all equipments will have the same synchronized time. And due to that fact that the equipments have to make analysis of the timing, I mean they have to understand what time is it right now, and all of them have to have absolutely same information, so they have to be synchronized by the NTP protocol. So the maximum hop count, it means that maximum distance between the client, the NTP client, and the NTP server, which is providing this, which is generating this synchronization, which is actually called the STRATUM 0, have to be 15. If our hop count will be 16 between the client and the STRATUM 0 NTP server, then our clock will not be synchronized. And how we can configure the NTP server. So in this example, we have with you the server, which is working as an NTP. So we can just turn on the function of the NTP in the packet tracer, and then our clients will be configured as this. So with this command NTP server, and we'll just define IP address of our server. So this IP address of server, so we are making this configuration in our router, so the time synchronization will come from the server. So actually we can try to do the same work. So let me take a look. Do I have it in? Did I prepare for you the NTP? So I think that I didn't prepare it yet, but we can create the new server in this topology, and the server's name is going to be the NTP server, and its IP address is going to be 50. So I also changed the IP address of the equipment from the IP configuration. And then I have to take a look for my NTP service, which is working or not working. So let's take a look. I heard this, and it's turned on. So I can turn it off or I can turn it on. And then authentication is disabled by default, and here's my timing, here's my date. And let me take a look while I'm not connected to the NTP server. I'll take a look for show clock, and it's saying that it is 1993. You see it's not correct clock, so that I'll go to make configuration of NTP server, and I'll define that my NTP server is going to be 10.50. Then I will be connected from the server to switch, so that my equipment, my router, will be able to contact the NTP server and get the proper time. So show clock is saying that now this is the April of the 2017. So my time is synchronized from the NTP server. This is how we can make configuration of the NTP client. So router is the NTP client. So we can verify our NTP configurations from the show NTP status. So let's do it on our router. Show NTP status, and it's saying that our time is synchronized, the clock is synchronized, and here's a lot of information about our time. So UTC and our time and the server who is giving this information and so on. Alright, continuing, SYSLOG. Alright, what is SYSLOG? SYSLOG is the message which is generated by the router or the switch, or it can be generated by the server or computer. And this message is providing the information about some changes in the router or in the switch, or some warning messages, or just some notifications and or acknowledgements. And this syslog messages in the Cisco equipment always appears in the console line, so that when you are connecting to the router, for example, and if you are turning off your interface gigabit 00, so for example interface gigabit 00, I'll type the command shutdown, so that I can see here the syslog message. And this syslog message is coming saying that link 5 changed interface gigabit 00 changed state to administratively down. This is syslog message. So I can turn on my interface and I can see the syslog message one more time. And we have here some levels of the syslog messages starting from 0 till 7. And notification that is created here is the place it on level number 5. Okay, so we can make filtration of the notification types. So we can see, we can make filter, just show me only very important information. But when you are making such kind of thing, like you write debug all command, it's actually not so good idea to type this command, but it will show us, just a moment, debug. So here we have to make filtration. All right, so the packet, all right. So now if any packet will try to enter to the router, we can see here information, what kind of information came to this interface at which time and so on. So that, by the way, we don't have here information at which time it came, so we can make configuration so that we will see the timing. And if our router will now generate the ping, for example, to the SYSLOG server, then we will see here that we have 4 ping messages, and each of this ping message is sending information, and after sending each of them we are receiving the reply. And this debugging is working on a level of the syslog number 7, which is not so useful to see, and which is not so useful to store it and save it in the external server, because you will have too much information about changes in your router. So syslog uses UDP port 514 to send event notification messages across IP networks to event message collectors. And so this is UDP transport layer protocol. Alright, so we have these levels. Levels starting from emergency. Emergency, it is system unusable, so it means that your device is not working. And next one is alert, immediate action needed, critical condition, when some errors are happening, a warning notification, normal but significant condition, for example, we turn off or turn on interface, it gives us syslog number 5. Informational messages, just some information appears in your screen. And debugging. Debugging is the process of the monitoring of some processes. In my example, I tried to debug my packages, IP packages, and now it is showing me. So I'm making ping, and I'm sending 4 packages, and I'm receiving 4 replies, and I'm seeing here all my debugs of these packages. Well, what else? Syslog message format. So in syslog message format, we can see sequence number, which stamps log message with the sequence number only if the service sequence number's global configuration comment is configured. And it's just giving the sequence number for this logging, for every log. Whereas timestamp is providing ability, so if we configure timestamp, then our syslog will, each of our log will be bounded with the time, at which time and at which date this log been generated. So for example, if we'll go to router configuration of the global configuration mode, so, and if we'll type the command, which we see here, service timestamp, timestamps, incomplete command. So let's take a look for logs. Okay. Alright, so let's continue. Date, time. So we don't have any variant. Alright, so okay, I'm sick. What else? Alright, I think that's it. And now let me take a look for my timestamp service, and by the way, I made up configuration of timestamp for log, so let me also write it for debug, and let me try to make ping now, and you see that my ping is now debugged with the information of the time. So this is 12th of the April of 2017, and this is second and milliseconds. Alright, facility, the facility of which the message refers, and severity, single digit code from 0 to 7, that's severity of the message. So that we saw it from the example when we go to interface gigabit 00 and turned off. So here we have this information of the severity. This is severity number 5, which is saying that the level of the logging is 5. Also we have mnemonic, the string that is uniquely described the message. And alright, the string that defines the string that uniquely describes the message. Okay, and we have also string containing details information about the event being reported, and here is the event. So it was turned off or turned on and so on. Let's continue. How we can make configuration of timestamp? We already did it, and we saw the difference between the with timestamp and without timestamp. This is how we can make configuration of the service syslog. In the packet tracer, we just click to the ratio button on, and it's starting to work. And we can make such kind of thing, like in our router, we are typing an IP address of that equipment, and then we are saying logging trap. It means that send only syslogs starting from level 4. It means that 4, 3, 2, 1, and 0. And then we are saying that logging source interface is gigabit 00. Now it's time to see to take a look for the router's file system. And in the router we have some directories. We have different types of the memories, including RAM, flash, NVRAM, and so on. So that in our files are stored in the flash. So we have, in this example, we have different flash memories, flash 0, flash 1, NVRAM, and we have other resources in which can be stored our files. If you'll type command dir, you will see immediately, because of the flash is the main is the storage for the operating system by default. When you type command dir, it is showing you the command which is same as if you'll type dir flash. What information is stored in the dir, in the flash, sorry, and how to make the backup of configuration files and IOs to with the TFTP server. Let's take a look for such kind of example. We have the packet tracer file in which we have the pre-configured TFTP server, which already have an IP address and which is going to be as the backup for storing of our configuration file and storing of our operating system. Now we will take a look. We'll firstly check the connectivity between our equipments. We'll send the packet from router to the TFTP server, and we'll send it one more time because of first packet failed due to ARP approximately. Yeah, we have connectivity. And now we want to take a look for the router's configuration file, and in our router we'll have the host name. Host name will be router 1, for example. And then we want to make save configuration which we have in the router 1 to the TFTP server. So we will send our information to TFTP server, but first of all we'll be sure the TFTP server is turned on. Yeah, it is turned on. And now from the router we will write the command like copy. You know that we can save from running configuration file to startup configuration file, but also we can save from running configuration file to TFTP server. So you type TFTP and colon. Then it's asking you what is the IP address of the TFTP server, and you have to type IP address of our router, of our server, 10.3. Then it is saying that what will be the destination file name. The destination file name will be router1 example. And it's saying that it is saved, so that if we'll go to TFTP server, we have to find with you the file which is called router1. How did we call it? Or R1 example. So I don't see it. It's here. Well, I don't see it here, so let's try to do it again then. And the remote host will be our IP address of the router. Is going to be 192.168.10.30, and our file name will be R1 example. Okay, so Well, I don't see it here somehow. So let me take a look. Do I have this IP address? Yes, 10.3. And what is the IP address of our second server? 10.40. Well, it's saying that it's already copied it, but let's try again. I think that I will just change the file name 10.3, and the file name will be AAA. Alright, saying that it's giving a report that everything is done. Let me go to the server, TFTP server. Maybe I have to refresh it somehow. Yeah, here it is. It means that I had to make refresh of this server, so that I have AAA and R1 example files. And look guys, what I will do, I will now take a look for my startup configuration file, which is the backup configuration file for my router, and I will see here that the host name is the router, but current my host name, which is in running configuration file, is R1. So all I need to do to check how I can restore my backup configuration file from the server, I have to erase my startup configuration file, and or maybe no, I will not erase my startup configuration file. I'll just reload my router, so that my router will lose all my current configurations. The current configurations stored the name of my router, and the name of the router being just it was router 1 R1, but now it is router. So that in case if I will now copy from TFTP to running configuration file from the server 10.30 file, which is called R1 example, then destination running configuration file, yes, and accessing to the router. And now you see, previously it was router, and now it became R1 because all my configurations been saved from TFTP server to the router. So we can save our configuration file in external equipment, so that we will be able to restore all of our configurations. Now it's time to take a look for how we can where our operating system is stored in the CISCO router. It is stored in the flash memory. So it's saying that we have such kind of file, and this file describes the operating system itself. And here we have some codes. The first code, C2900, is saying that what version of the what series of the equipment is used. It is 2900. So our router is in the series of the 2900. It's actually 2911 router. Afterward, we can see here that we are using the operating system, which is universal, which is working with some basic networking protocols, and we can make upgrade to the security packet when we are making the licensing. Afterward, we can see here the type of the memory which is used. We can have different types of memory, but M, it means that this is the RAM memory. Also we have Z, it's type of the compression. SPA defines the CISCO signature, and we have the version of the operating system, and extension of file is bin, which is saying that this is a binary executable file, which is actually the operating system. So what we can do with the operating system, we can also copy our operating system from flash. And alright, what I can type next to TFTP. Alright, and the source file name will be, so I'll just copy this file and I'll paste here this name, and the address of remote computer is going to be 1030. It's our TFTP server. The destination file name will be the same. And look, I copied my file operating system to TFTP server. So now we'll check it out. Did we receive it? So maybe I should refresh it again. maybe it is here. Yeah, it's one of this operating system. I think it's this one. Okay, maybe it was already here, but we sent the same file and it is been rewritten. All right. Also, you can copy from TFTP to Flash, and the file name will be same. And the source address from where we'll get this file, and this destination file name will be called 192.168. So our operating system will be called differently, or we can just paste the previous name, but we'll change something. For example, we'll say that here it's going to be 1 or new, and trying to receive this file from the TFTP server. Alright, so let's try to stop this process because it is not giving us any positive feelings. Copy from Flash to TFTP. Source file name will be like this, and the IP address of the server is 3, and destination file name is going to be changed. For example, it will be new iOS. Here it is. And if we'll take a look for the flash memory, we have to find out here the file which is called the iOS or dir flash. Oh, I don't see it here. And what did I copy? I copied I copied it one more time. From Flash to TFTP, I have to copy from TFTP to Flash. And from TFTP to Flash, address will be 10.30, and the file name will be this file. And destination file name new iOS. Here it is. Dir flash will show me that I have this file, which is absolutely with the same size, which name is new iOS. And I can then go to global configuration mode, and I can type the command which will help me to boot from this flash memory card. And just a moment, boot system, and then I can say that flash and the name of the file new iOS, so that when I will restart my router, it will start to use another operating system. It means that now in my router I have two operating systems, one of them old operating system C29 and so on, and new operating system which I just as the simulation I just downloaded from the internet and I just pasted to my TFTP. From TFTP I copied it to my router, and now I'm booting it from the flash memory card by using the command boot system flash and the name of this file. Let's continue with the iOS image file names. In iOS image we have first thing what you see, it is the series of the equipment which you use in and then you can see the universal K9 which is universal operating system, but which can make some encryption. The K9 defines that this operating system can make encryption. Then we can see in which memory it is stored. RAM, it means that this operating system now is in the RAM memory. It's running from RAM memory. But we have different variants: flash, ROM, and relocatable. SPA defines the digital signature authenticator. And then we have the operating system with some release numbers, and then we have file extension. Alright, licensing overview. By default, when you are getting the standard Cisco router, it is working with the operating system IP base, which can work with a lot of protocols, which can do a lot of jobs, but not so specific. So if you want to have the router which can work the call manager, then you have to make the licensing to unified communications, which will support the voice over IP, which will support the registration of the accounts of the phone numbers. If you are working with the as an internet service provider, then it will be better to upgrade your operating system, upgrade your licensing to the data. And if you want to have such kind of technologies which will work on your router, like an VPN and security stuff, then you have to use the licensing to the security level. And IP base, as been told before, it's just like a standard licensing, which you don't have to upgrade. How licensing can be processed? So you first of all have to you have to contact to Cisco license manager. You have to get this license. You have to make a purchase. You'll get this file, licensing file. Then you will install it into your router or switch. And if you'll take a look for the show license UDI, you will see that your UDI is consists of serial number and PID number, and it can be seen if you're using one of the 19 or 29 router or higher level, then you can see it on the front side. So here is the spatial sticker, which can be seen without looking for the backside of the router. And after you will install this, after you will get this licensing from the, for example, TFTP server, in the same way as we did it with you with the operating system, you can take it from the TFTP server, and afterward you can install this license. You can type license, install, and then you will just provide the directory from which your license will be installed. And then you will see that if you will type the command show version, you will see that your license is upgraded, and now you have security license back. And also, if you'll type the command show license, you will see that your license is turned on, it's active, and so on. Also, you have ability, if you don't have money, or if you don't know do you need to have this license or not, you can try to use a trial version of the license. Evaluation right to use license. Okay, so we can make the acronym for that ERTUL, maybe like this, so that you can type the command license, accept end user agreement, license boot model, and here it is. And afterward, when you'll type show license, you will see that how many weeks, how many days left until that moment when your license will be expired. Backup the license, so you can save your license to flash memory card if you wish, or if you want to store it in the TFTP server, you can do the same. License save, and you can just give directory where it will be saved. Uninstalling the license. To uninstall the license, we'll just type the command. We'll first of all disable the technology packet. To disable it, we have to say license boot model, and then disable. Reload the equipment, and then license clear. Okay, then in global configuration mode, no license boot, and so on. Alright, this is the end of the last chapter in routing and switching 2 book. I hope that we'll soon start with you routing switching 3 book, which you can find on the same YouTube channel. If you have any feedbacks, please compose me a message, or just you can just write the comments. You can like this video if you really like it, and it's just good idea to subscribe to this channel to be able to see all fresh new video lessons.